Okay, today we're looking at finding reference angles. Got to remember we have 4 quadrants, and the signs of X and Y in the first quadrant is plus and plus. Quadrant 2, X is negative, Y is positive. Quadrant 3, we have 2 negatives, X and Y. Quadrant 4, we have a positive X and a negative Y. The reference angles in quadrant 1 are simply theta. That's the symbol for theta. It means angle. So at 30 degrees, you can see it's green, 45, and 60 degrees. Those would be our reference angles, simply stated in quadrant 1. That's the cosine and the sine for a 30 degree. Cosine and sine for a 45. And for a 60 degree angle, the cosine is 1/2 and the sine is the square root of 3/2. Now everything we do from here on is based on those cosines and sines for those specific angles. You might want to pause it, copy that down. It might be useful. So let's look at all the reference angles. They're all based on the same angles, and there it is. The only thing that's going to change are the signs of the X and Y depending on the quadrant. And remember, cosine is with X, sine is the Y value. I remember it because X comes before Y in the alphabet and C comes before S in the alphabet. So that's basically how these will change depending on where your terminal side falls. What about quadrant 2? Find the reference angle if you just take 180 and take away whatever the angle you're asked for. So 180 minus 120, that's going to be the reference angle is 60 degrees. 180 minus 135, the reference angle would be 45 degrees. 180 minus 150, the reference angle is 30. Remember, X is going to be negative, Y is going to be positive. So what happens when we move on to quadrant 3? Take theta and subtract 180, and you'll find the reference angle. So we have 210 minus 180 is 30 degree angle is the reference angle. If we have an angle of 225 and we take away 180, the reference angle is 45 degrees. And finally, if we have an angle 240, take away 180, we get a reference angle of 60 degrees. Notice all reference angles are created by making a vertical line down from the terminal side to the x-axis. You never head towards the y-axis. That's a common mistake. In quadrant 3, your cosine, the x value will be negative, and so will the sine. It will also be negative. In quadrant 4, it's 360 minus whatever your angle, theta. So 360 minus 300 leaves you with a 60 degree angle. 360 minus 15 gives you 45, and 360 minus 330 gives you 30 degrees. In quadrant 4, X is positive, the Y is negative. So I've drawn my angle. I know I've already done the math. If I have 225, I take away 180, I have a 45 degree angle. That is the reference angle. And 45 degree angle is the cosine and sine of the square root of 2/2. They're both the same. They're both negative because that is what you have in that quadrant. This is going to be in the 4th quadrant, 330 degrees. If I take 360 and take away the 330, I end up with a 30 degree angle as my reference angle. And so for every 30 degree angle, you have the square root of 3/2 is the cosine, 1/2 is the sine. The only difference here is it's in quadrant 4. So the rules for quadrant 4 are the x would be positive, the y would be negative, and there we have it. Let's do the cosine of 225. So I make a 225-degree angle. I see that it's in the third quadrant. And when I take away 180, I find that it's a 45-degree angle. Well, the cosine and sine for 45-degree angle is the square root of 2 over the square root of 2. And they're both identical. So what's going to change? What has to happen here if it's in the third quadrant? Think about what we talked about with sines. Well, we know that both the x and y are negative in that quadrant. So I put my negatives in front of the square root of 2 over 2 for both cosine and sine, except what was my original question? What's the cosine of 225? Well, the cosine would just be negative the square root of 2 over 2. And there you go. I have answered that question. Well, that's it, folks. Hope that helps and gives you some idea of how to find the reference angles and the coordinates for these set angles in a unit circle. Remember, a unit circle is called a unit circle because the radius is always 1 unit. All right, thanks for watching and have a great day.